Hi, my name is Brooke Martin, and I am here to talk to you today about antibiotic resistance in Atlanta waters. The Chattahoochee River provides drinking and recreational waters to millions of people in Georgia. Most people, including me, are worried about the cleanliness of these recreational waters. Water runoff from storm events can allow pathogenic bacteria to enter the water and disturb the environmental balance. Detection of pathogenic bacteria is achieved by quantifying coliforms in water. Coliforms are bacteria commonly found in the intestinal tracts of animals and the environment. A prime example is E. coli. Waterborne infections are typically self-resolved but can become difficult to treat if the bacteria are resistant to treatment. The objective of this study is to quantify the abundance of coliforms in freshwater sites across Atlanta and identify antibiotic resistance genes in water samples. It is hypothesized that there will be a higher abundance of detectable bacteria after rain as seen in previous studies. It is hypothesized that isolates will be more resistant to kanamycin since it is frequently used to treat pathogens acquired from an environment. To evaluate these hypotheses, we tested 5 locations around the Atlanta area from February 15th to March 2nd. Figure 1 shows the map of sample sites and descriptions of the sites. In summary, 2 sites were along the Chattahoochee River, 2 sites were green infrastructures, and 1 site was a river upstream of the Chattahoochee. All of the sites have recreational and residential uses except for the suburban stormwater, which is just residential. Looking to the right, this is the workflow for testing the hypothesis. First, we will collect our water samples. We will detect and quantify fecal coliforms using MTEC and IDEX methods. We will then isolate E. coli from NTEC samples. We will also plate our water samples on non-selective media. We will isolate and characterize unique colonies using gram staining. We will then subject our isolated colonies from water samples and E. coli and test their antibiotic susceptibility. We will then do DNA extraction followed by 16S rDNA PCR to identify our bacteria further. So now we're moving on to results. Figure 2A is showing the log of colony forming units per 100 milliliters inoculated onto nutrient media in relation to rain events and the average temperature that day. Holcomb Bridge and Riverview Landing have the highest colony forming units on March 2nd. Both of these sites saw its lowest point on February 25th. Suburban stormwater colony forming units peaked on February 17th and are reduced in abundance over the course of the sampling. The wetlands and Peachtree Creek peaked on February 25th. Figure 2B is showing the log of the most probable number of fecal coliforms using IDEX methods. Holcomb Bridge, suburban stormwater, and wetlands had the highest most probable number on February 17th, and Riverview Landing and Proctor Creek had its highest most probable number on March 2nd. It is worth noting that wetlands and Proctor Creek had their lowest points on February 25th. Figure 2C demonstrates E. coli detection using IDEX methods. Holcomb Bridge, suburban stormwater, and Peachtree Creek had the highest values on February 17th and decreased in value over the course of sampling. Wetlands had the highest most probable number on February 25th, and Riverview Landing had the highest most probable number on March 2nd and had its lowest dip on February 25th. Figure 2D is showing the Environmental Protection Agency's method 1603 used to detect E. coli. The red line on the graph represents the EPA's beach action value, which is a standard used to test the quality of water. Above the line indicates the water is not up to standard. Holcomb Bridge, suburban stormwater, and Peachtree Creek had the highest values on February 17th and decreased in value over the course of sampling. Wetlands had its highest value on February 25th. Riverview Landing had its highest value on March 2nd and had its slowest dip on February 22nd. Riverview Landing and Peachtree Creek were above the beach action value every day sampling occurred. Riverview Landing had between 19 and 414 more colony forming units than recommended by the EPA. Peachtree Creek had between 19 and 82% more colony forming units per 100 mils than recommended by the EPA. Figure 3 is showing the percent resistance of isolated colonies from each site. Holcomb Bridge was not included since only one isolate was tested and it was susceptible to all antibiotics. Of the isolates, 52% were resistant to tetracycline, 11 were resistant to kanamycin, 82 were resistant to novobicin or erythromycin. Of the suburban stormwater sites, 44 were resistant to 2 antibiotics and 33 were resistant to 3 antibiotics. For wetlands, 70% of isolates were resistant to 3 antibiotics. For Riverview Landing, 75% of isolates were resistant to 3 antibiotics. And for Peachtree Creek, 20% of the isolates were resistant to 2 antibiotics, 70 were resistant to 3 antibiotics, and 10 were resistant to all 4 antibiotics. Figure 3b is comparing percent resistance of E. coli compared to unknown isolates. All of the E. coli isolates were resistant to erythromycin. 15% of isolates were resistant to kanamycin. The unknown isolates had the highest resistance to novobicin at 58%. All of the unknown isolates were susceptible to kanamycin. The conclusions that we can come to from the results reject the hypothesis that more coliforms will be seen after rain events. All of the sites except for Riverview Landing and Peachtree Creek had peaks in fecal coliforms on days it did not rain. We are also able to reject the hypothesis that isolates will be most resistant to kanamycin. In fact, kanamycin was the most effective drug at inhibiting microbial growth. So talking into the discussion, all of the sites except for the suburban stormwater had higher amounts of bacteria on days that it rained. This could be due to the fact that the suburban stormwater site was more residential. Residential areas are known to have lower bacterial loads compared to recreational. Also, Riverview Landing and Peachtree Creek need to take steps towards increasing the quality of their water. Implementing green infrastructure like in suburban stormwater and wetlands could assist in bringing the waters up to standards. Additionally, the most effective drug at inhibiting the bacterial growth was kanamycin. If there was a waterborne outbreak, kanamycin could potentially be used to treat the infection. In the future, 16S rDNA PCR will be done to identify the selected isolates. Further, qPCR will be done to determine the mechanism of resistance samples are using in the presence of erythromycin. Thank you for coming to my